something extraordinary and entirely unexpected happened to the interstellar object 3IATLAS as it sped through our solar system. And astronomers around the world are still struggling to understand the details. The object, already remarkable for being one of the few known visitors from beyond our solar system, suddenly exploded near the point in its orbit closest to the Sun. This dramatic event caught the scientific community by surprise because 3IATLAS was not expected to display any violent or explosive behavior based on our current understanding of cometary or asteroid. Physics observatories both on Earth and in space recorded a sudden brightening followed by fragmentation, producing a cloud of debris and an energy release that seemed disproportionate to the size of the object. The scale, timing, and intensity of the explosion raised more questions than answers, sparking an international effort to analyze the event and understand the forces at play. 3IATLAS was first detected only recently, and its hyperbolic trajectory immediately marked it as an interstellar visitor. Unlike comets that orbit the Sun in predictable elliptical paths, this object arrived at high velocity from beyond our solar system and will eventually depart back into interstellar space. This alone made it a unique subject of study, offering a rare glimpse into material formed around another star system. Scientists had anticipated a typical cometary response to solar heating, expecting the release of gas and dust in a gradual process as it approached the Sun. However, the sudden explosion defied these expectations, revealing a level of complexity in interstellar objects that challenges existing models. One leading explanation for the explosion is rapid internal heating, causing a catastrophic release of pressure as 3IATLAS approached perihelion. The Sun's intense heat could have caused volatile ESAs inside the object to sublimate extremely quickly. This sublimation can generate enormous pressure if trapped beneath the surface, potentially leading to a sudden rupture or explosive fragmentation. This is similar to a pressure cooker that cannot vent properly. But even this analogy falls short of capturing the sheer scale of energy released. The debris pattern observed suggests a violent, almost instantaneous disintegration rather than a gradual shedding of material, which implies a sudden, internal event rather than standard thermal outgassing. Another puzzling aspect is the composition of 3IATLAS, which remains largely mysterious. Observations indicate that it may contain unusual metal-rich or dense components. Unlike typical comets in our solar system, these unique materials could interact differently with solar radiation and heat, potentially triggering chemical or physical reactions that ordinary cometary models cannot predict. Additionally, cosmic radiation exposure over millions of years in interstellar space may have altered its internal structure, making it far more susceptible to sudden explosive behavior upon encountering the Sun's intense energy. This suggests that interstellar objects may possess compositions and histories radically different from anything previously observed, expanding the range of possibilities for astrophysical phenomena. The event also invites comparison with other known interstellar visitors, particularly Oumuamua, which passed through our solar system a few years earlier. Unlike 3IATLAS, Oumuamua displayed unusual acceleration without any visible outgas, challenging astronomers to explain its behavior within standard models of physics. Some scientists suggested cometary activity hidden by a thin crust, while others speculated about more exotic mechanisms including radiation pressure or even unusual material composition. The explosion of 3IATLAS adds another layer of mystery, demonstrating that interstellar objects can behave in ways that are entirely unexpected, defying assumptions based on local solar system bodies and highlighting the diversity of materials traveling across the galaxy. Researchers are now meticulously analyzing every available data point to understand the explosion. This includes high-resolution imaging of the debris cloud, spectroscopy to identify chemical signatures, and computer simulations to model potential fragmentation scenarios. Theories range from trapped gas explosions and chemical reactions triggered by solar radiation to mechanical failures caused by accumulated structural weaknesses over eons of travel through interstellar space. Each hypothesis has its strengths and limitations, and scientists continue to refine their models to account for the unusual behavior. Observe the explosion of 3IATLAS also offers a rare opportunity to study interstellar material at close range without entering our solar system. We would not have been able to observe this object's behavior or analyze the debris it produced. The material released can provide clues about its origin, composition, and the conditions in which it formed potentially billions of light away. This has implications not only for understanding interstellar objects themselves, but also for broader questions about planetary system formation, the distribution of elements across the galaxy, and the diversity of cosmic materials. Moreover, the sudden and unanticipated nature of the explosion underscores how little we truly know about the universe. Even objects that appear small and relatively simple can harbor extreme complexity, shaped by processes that are completely alien to the conditions found in our solar system. Scientists emphasize the importance of continuous observation and advanced telescopes, which made it possible to witness and record this rare event in real time. The explosion has energized the scientific community, pushing astronomers and physicists to question assumptions and expand theoretical models to accommodate such unprecedented behavior. Some researchers have speculated about more exotic possibilities, such as the presence of previously unknown volatile compounds, interactions with cosmic rays, or even mechanical instabilities caused by repeated thermocycling over millions of years. The diversity of potential explanations reflects the complexity of interstellar objects and the extreme conditions they endure while traveling across vast regions of space. Some of the simulations suggest that even minor variations in internal composition could result in dramatically different responses to solar heating, potentially explaining why the explosion was so sudden and so energetic. In addition, 2. The scientific implications. The explosion of 3IATLAS captures the imagination, because it reminds us of the dynamic and unpredictable nature of our universe from the perspective of a casual observer. Space may seem empty and static, but events like this demonstrate that even tiny objects can undergo catastrophic transformations, producing phenomena that can be observed across millions of kilometers. Scientists are learning not only about the specific characteristics of 3IATLAS, but also about the broader population of interstellar objects, many of which may be traveling through the galaxy entirely unnoticed. The event has also sparked discussions about monitoring and preparing for interstellar visitors in general. While the likelihood of an object of this size posing a threat to Earth is extremely low, understanding the composition, behavior, and potential for explosive events is scientifically valuable and could inform future missions or observation strategies as we continue to detect more interstellar objects. Each one provides a unique laboratory for testing theories of physics, chemistry, and planetary science under conditions vastly different from our own solar system. In conclusion, the unexpected explosion of 3IATLAS near perihelion represents a dramatic reminder of the mysteries of interstellar space. Each observation challenges existing theories, from the thermal and mechanical properties of comet-like bodies to the chemical and physical diversity of interstellar materials. Scientists are analyzing the data meticulously, running simulations, and refining models to understand the forces that could have triggered such a violent event. The explosion serves as a vivid example of how dynamic and unpredictable our universe is, and highlights the importance of continuous observation, innovative research, and curiosity-driven exploration. The study of 3IATLAS not only expands our knowledge of interstellar objects, but also provides a window into the processes that shape the galaxy and beyond, demonstrating that even in the vastness of space, extraordinary and unthinkable events can occur, challenging our understanding and inspiring wonder at every turn.